Hello everyone. I hope you all are safe and fine at your homes. Today we are going to start a new chapter named Acid, Base and Salt. In this chapter, initially we are dealing with definitions of acid and base. We are dealing with definition of acid and base. To define acid and base, we are using a number of various concepts. Concepts which define acid and base are, there are number of concepts which gives different definitions of acid and base. We are discussing four concepts. The first one is classical concept. Second concept we are discussing Bronsted-Lowry concept. The second one is Arrhenius concept. The third concept, Bronsted-Lowry concept. And the last concept is Lewis concept. These four concepts give different definitions of acid and base. In today's lecture, we are going to discuss the above two concepts. So, let's start with the first concept, classical concept. Note it down. Classical concept is the very first concept which define acid and base. So, according to classical concept, what are acids? According to classical concept, the first definition of acids is compounds which are sour in taste. Compounds which are sour in taste. For example, citric acid. This acid present in citrus fruits. Acid present in citrus fruits. Citrus fruits simply means khatte fal. For example, lemon, orange, etc. The second definition of acid according to classical concept, compounds which convert blue litmus solution, compounds which convert blue litmus solution into red. ऐसे कंपाउंड्स जो ब्लू कलर के लिटमस सॉल्यूशन को किसमें कन्वर्ट कर दें, रेड कलर के लिटमस सॉल्यूशन में, उनको हम क्या बोलते हैं, एसिड्स. लिटमस सॉल्यूशन एक्ट एज इंडिकेटर्स. लिटमस सॉल्यूशन क्या होता है, इंडिकेटर्स होते हैं. इंडिकेटर्स मींस सब्सटेंसेस व्हिच हेल्प्स अस टू डिस्टिंग्विश बिटवीन एसिड एंड बेस. ये हम आगे डिस्कस करेंगे. Next definition of acids on the basis of classical concept, compounds which on reaction with active metals release hydrogen gas. Such compounds which on reaction with active metals release hydrogen gas are known as acids. One more definition according to classical concept. Note it down. The fourth definition according to classical concept. Compounds which conduct electricity are known as acids. Compounds which conduct electricity are known as acids. The last definition of acids according to classical concept is compounds which loses their property on reaction with bases. So, according to classical concept, we have 5 definitions of acids. First definition, compounds which are sour in taste. Second definition, compounds which convert blue litmus into red. Third definition, compounds which gives hydrogen gas on reaction with active metals. Fourth definition, compound which conduct electricity are known as acids. Fifth definition, compounds which loses their property on reaction with bases are known as acids. Now, we start discuss about definition of base on the basis of classical concept. Just a minute ago, we discussed about the definition of acids. Now, we discuss about the definition of base. First definition of base according to classical concept is compounds which are bitter in taste. Compounds which are bitter in taste. Bitter means kadwe. Second definition, compounds which are soapy in touch. Or we can also say slippery in touch. Third definition, compounds which turns red litmus solution into blue. Next definition, compounds which conduct electricity. In the last definition of base, compounds which conduct electricity. Compound which loses their property on reaction with acids. So the last two definitions in both cases are same. Both acid and base conduct electricity. And the last point, both acid and base loses their property on reaction with each other. The starting three definitions are quite differ from each other. So all the definition as we observe based on the operation or any kind of condition. So we are allowed to say these definitions are known as operational definitions. So the definition given by classical concepts are known as operational definitions. These definition of acid and base are known as, what we call them, operational definition. Clear? This is all about classical concept. Next we are dealing with the definition of acid and base according to Arrhenius concept. So let's start our next concept, which is Arrhenius concept. As similar to classical concept, Arrhenius concept also define acid and base. Arrhenius concepts define acids according to Arrhenius concept. Compounds which contain hydrogen and release hydrogen ion when dissolved in water. So according to Arrhenius, acids are the compounds which contain hydrogen and release hydrogen ions when dissolved in water. Let's discuss some examples. First example, when HCl dissolves in water, it gives us H positive and Cl negative. HCl is known as hydrochloric acid. HCl is known as hydrochloric acid. H2O is water, H plus is hydrogen ion, and Cl negative is known as chloride ion. Let us take one more example. H2SO4 in presence of water gives us 2 H positive ions and SO4 2 negative ion. This compound H2SO4 is known as sulfuric acid. Again water, hydrogen ion, and this ion, polyatomic ion, is known as sulfate ion. Sulfate ion. Just a minute ago I used the word polyatomic ion. Sulfate is an example of polyatomic ion. Those ions in which 1, 2 or more than 2 atoms combine. Like in sulfate, sulfur and oxygen, 2 atoms are present. So sulfate ion is the example of polyatomic ion. Arrhenius also helps us to classify acids in two types, strong acid and weak acid. Now we discuss about the examples of strong acid and weak acid. Classification of acid. First part is strong acid. Those acids which are completely dissociate in water are known as strong acid. Those acids which shows complete dissociation in water are known as strong acids. For example, HCl, H2SO4, HNO3, HClO4, etc. We discussed the dissociation of these two acids in above examples. Now we discuss the dissociation of these two acids. HNO3, the name of this acid is nitric acid. On dissolving in water, completely dissociation. This type arrow represent complete dissociation, results into the formation of H positive and NO3 negative. NO3 negative ion is known as nitrate ion. Consider one more example, HClO4. This acid is perchloric acid. The name of this acid is perchloric acid. When perchloric acid is dissolved in water, it shows complete dissociation and gives H positive and ClO4 negative. This ion is known as chlorate ion. So let's revise. Strong acid, those acids which shows complete dissociation in water are known as strong acids. For example, HCl, H2SO4, HNO3, HClO4, etc. These two dissociation. This arrow represents complete dissociation. Next, weak acids. Note it down. Next we discuss weak acids. Next we discuss weak acids. Those acids which shows partial dissociation in water are known as weak acids. Revise the definition. Those acids which shows partial, or you can allow to say incomplete dissociation in water are known as weak acids. For example, CH3COOH, H2CO3, H3PO4, etc. These are the examples of weak acids which are not completely dissociated. CH3COOH on addition of water gives us acetate ion and H positive. This acid is known as ethanoic acid. And the common name of this acid is acetic acid. When acetic acids dissolve in water, gives us acetate ion plus hydrogen ion. Next example, H2CO3. This acid is carbonic acid. When carbonic acid dissolves in water, it gives us 2H positive. It gives us 2H positive and CO3 2 negative. This ion is carbonate ion. This ion is carbonate ion. So this kind arrow represents partial dissociation, and such acids are known as weak acids. On the same lines, do the dissociation of this acid, H3PO4. The name of this acid is phosphoric acid. One thing is common in both strong acid and weak acid. They release H positive ions in aqueous solution. Now we start define base according to Arrhenius concept. Acid part is complete. Now we deal with base part. According to Arrhenius concept, base are the substance compounds which contain hydroxyl group and release hydroxyl ion on dissolution in water. I hope the definition is clear. Substances which contain hydroxyl group and release OH negative ions on dissolution in water. For example, NaOH, CaOH twice, etc. These two compounds contains OH group. The first compound, NaOH, is known as sodium hydroxide. This compound is sodium hydroxide. This compound, calcium hydroxide. And when these two compounds dissolve in water, they release hydroxyl ion. The first one, NaOH, in presence of water gives us sodium ion and hydroxyl ion. The second one, calcium hydroxide, on dissolution in water gives us calcium ion and hydroxyl ion. Now again, this kind arrow represents complete dissociation. This kind arrow represents partial dissociation. So bases are further classified as strong base and weak base. Note it down. Classification of base. Our next topic of discussion, classification of base. Base are classified into two types. is strong base. Compounds. Alright, bases here. Bases which completely dissociate. Bases which completely dissociate in water are known as strong base. Are known as strong base. For example, KOH, potassium hydroxide, when dissolved in water, it gives us potassium ion and hydroxide ion. This arrow represents complete dissociation. Next, weak bases. One is strong base which completely dissociate in water. Strong bases, examples KOH, NaOH, etc. Examples NaOH, KOH, etc. Next, we are dealing with weak base. How we can define weak base? Base which partially or incompletely dissociate in water are known as weak bases. How we can define weak bases? Bases which partially dissociate in water are known as weak base. Not completely dissociated. Examples: NH4OH, AlOH thrice, MgOH twice, etc. The first compound is known as ammonium hydroxide. This one is ammonium hydroxide. Example of weak base: AlOH thrice is aluminium hydroxide. And the last base, or again one more example of weak base, magnesium hydroxide. Magnesium hydroxide. Let's now do the dissociation of these acids. When ammonium hydroxide dissolves in water, it partially dissociates and gives us ammonium ion and hydroxide ion. This ion is ammonium ion. And OH negative, hydroxide ion or hydroxyl ion. AlOH thrice, on dissolution in water, again partially dissociated and gives us aluminium plus 3 and 3 OH negative hydroxide ion. One thing is common in both strong base and weak base: they release OH negative ion on dissolving in water. Clear? Note it down. These are the following classification of acid and base on the basis of Arrhenius concept. One more thing about Arrhenius concept. Arrhenius defined neutralization. Arrhenius defined neutralization process. According to Arrhenius, neutralization process is the process in which hydrogen ion and hydroxyl ion combine with each other and forms water. So, according to Arrhenius, what is neutralization process? The process in which H positive ion combine with OH negative ion and form unionized water is known as neutralization process. This is all about Arrhenius. Last topic is limitation of Arrhenius concept. Limitation of Arrhenius concept. The first limitation of Arrhenius concept. This concept is limited to water. Simply means if water is available, only then Arrhenius able to define what is acid, what is base. If water is not present, Arrhenius is not going to be define what is acid or what is base. Second definition, unable to explain the reaction of acid and base in absence of water. If water is not present, then according to Arrhenius, acid and base are not going to react with each other. The third limitation of Arrhenius is unable to explain the acidic and basic character of following compounds, that is NH3, CO2, Na2CO3, etc. About these compounds, Arrhenius didn't give any kind information to us. This is all about Arrhenius concept. In today's lecture, we discussed two concepts. First one is classical concept, second one is Arrhenius concept. The next two concepts we are going to explain in our formal lectures.